body that we can quantify here. So we said there are two additional variables we can quantify. One of them is power, which we just addressed, and the other one is actually inherent in the power equation that we've previously used, and it is electrical energy. Okay, so the second variable we can quantify is electrical energy. Electrical energy. So if P is equal to W over T, or work or energy per unit time, then energy is simply equal to the power times the time. Okay. So, I want to focus on the power aspect though, the electrical energy aspect. It's a very simple formula, and it's just a rearrangement of the formula that we have already used. Just know that this W here represents work, but also electrical energy, which we measure always in joules. And P is power, which we measure in watts, and T is time, which we measure in seconds. Just as a reminder, okay? So we may revisit this and come back to it in a different context. Okay. Actually, let's solve it. So let's solve a problem using this. So let's say on average each morning I use my hair dryer for, let's say I use it for 20 minutes. So I think I have to make space. Oh no. What happened? It doesn't want to let me. Alright, let's see if I can highlight from the board. There we go. That's what I wanted to do. Okay, let's go group. Come on. I was laughing to myself because you guys always hear me say, I wish I had a chalkboard and stuff. And when we found out that school was going to be out indefinitely, I was like, be careful what you wish for. I was like, I went to the store, I almost bought a chalkboard, but I actually got graphing paper pads, which I prefer. So let's solve a problem. Miss Spin uses her 1800 watt hair dryer. Okay, I am way understating this, but we're going to say for 20 minutes each morning. Each morning. How much electrical energy is expended? Well, the first thing I'm going to need to do is take this 20 minutes and I'm going to want to convert it into seconds. So 20 minutes is how many seconds? Well, we have 20 minutes times 60 seconds per minute. That allows us to divide out minutes. Okay? So we have 1200 seconds, right? So this is going to be 1200 seconds. Okay. 1800 watts. So we're going to plug into electrical energy is equal to the power rating of the hairdryer times the amount of time it's used for. So W is equal to, if 1800 watts times 1200 seconds, and let's see, 1800 times 1200, okay, so 2,160,000 watt seconds, in other words, joules. Okay. You can express it either way. Okay. So that's just an application of solving for electrical energy. But I do want to revisit, as I was starting to mention before, power and how we can incorporate this variable into our RIV chart. So we're going to revisit that last problem that we did, and I want to make an addition to this chart. Oops, I'm sorry. Please let me highlight. Thank you so much. Sometimes you have to talk to the smartboard. Group it, make it smaller. Now what I'm going to add to this chart is one additional column after the fact, and that column is going to be a power column. So instead of it being an RIV chart, if we are given the wattage of a light bulb, for instance, or if we want to find the wattage based on the current in the circuit and the resistance, we can add this into the equation. Okay, so we have our power rating, and the nice thing about the layout of this chart is we know that power is most easily found by taking the product of the current and the voltage. So now I can just go across, and the power across resistor 1, or the power dissipated to resistor 1, is going to be 2 amps times 4 volts, which is 8 watts. We'll multiply across here, right, because P equals IV. So reminder, P equals IV. So I'm finding power dissipated to resistor 1 was 8 watts. Power dissipated to resistor 2 will be 2 amperes times 8 volts, which is 16 watts. Power dissipated to resistor 3 is going to be 24 times 2, which is 48 watts. By the way, as a check, power total should be additive and should be equal to what we multiply across here. So 2 amps times 36 volts is 72 watts. So if these add up to 72, which it seems like they do, then you're in great shape. So sometimes this will be useful to you. Then we would want to say P1 is equal to I1 V1, and we would want to show that work 2 amperes times 4 volts, which is equal to 8 watts, and so on. Do the same